Just I picked up a problem. The source is not monochromatic. Most of the problems of photoelectric what we have is we discuss for monochromatic, so like a monochromatic source. Here, chromatic source is what he has brought. That's all finished. Nothing big. Then what happened to photons? Yes, we do get a photons whose energy now varies in between. They are incident on a plate. So when a chromatic radiation, if it is incident, if not a monochromatic, or so like a, or better say like a chromatic radiation is incident only in a on a metal surface, then what conditions will arise? That is what we are going to discuss here. There's a constant or visible range. So shall I just call this the chromatic light? Okay, afterwards. This beam of area 1 meter. Okay, now we know intensity into power, intensity into area will get power. The collected plate is sufficiently positive so that tube is in saturation mode. So what all current flows to saturation? Assume that each capable photon liberates 1 electron. Okay, what function is? What is the current in the tube? Is asking. How to bring that? So is asking that saturation current. And we do have photons of different wavelength. So shall we do one thing? 400 to 700. So 300 different photons are there. We'll calculate energy due to each photon will add up. But are they specific 401, 402? The overall the wavelength varies from where? 400 to 700. I don't think so. We should do like that because if they're given some specific like 400, 401, 402, okay, we could have thought. It ranges from 400 to 700. So some sort of integration is needed. This is a basic idea you have to put in. Okay, let's take the small spectrum where the wavelength, let it be lambda. Oh, so d lambda, let it be here. The energy, the light corresponding to this will be incident. Okay, let it be lambda. Let it be di, let it be this one. So what is the expression for saturation current? Saturation current, again the same thing. The in power intensity into area by energy of photon. How to write equation? This is the very important. What is di by d lambda value? I think dr by d lambda is the one fixed value, no? It is. How much it is? 0.031. Call say some alpha something it is. Huh? Let me start here. Di by d lambda. Okay, that directly the saturation current is equal to intensity. So di power no. So di into a by sc lambda e into di into a sc by lambda. Why this c? Because what is this quantity? Number of photons that are incident whose intensity is say di and having a wavelength lambda. Okay, this one into there will be number of photons emitted per second. For each photon will give 1 electron. So into charge of that will give the current. Okay, this quantity is per second. Number of photons per second will give 1 electron. each photon will give one electron. So therefore, the saturation current, we can directly write it here. Quantum efficiency, anything. Okay, that's what it's saying. Okay, I do have. So what is di? Di I can write as alpha d lambda e a lambda hc into di. dis. This is, yeah. Alpha lambda d lambda. So the wavelength is from lambda 1 to lambda 2.
Lambda
Okay, I
1
think
to threshold wavelength, no, sir.
check it, that threshold wavelength will be
It's less than 700, sir.
700.
Less than 700.
Less than 700. Okay, then I'll put it lambda naught. So SC by lambda naught is equal to 2 electron volt. Okay, because those which are more than that will not liberate. Threshold wavelength is, we should calculate, no? It is. Anybody, how much will get lambda naught?
21 nanometers, sir.
21 nanometer. Huh? No, check it once.
621, sir.
621. Armstrong, sir?
Nanometers.
Nanometer. Okay, 621 nanometer. Okay, work function he has given. What is this? What is this? The saturation current that flows per particular photon of wavelength lambda, where the intensity of that is di. Then di, I'll substitute from here. What is alpha is 0.031. This now I'll integrate. So what is E? E is a charge of electron, 1.6 into 10 to the power of minus 19. Very troublesome symbols all, even in exam, no? Even if you're able to think, maybe we may go wrong in what, like substituting symbols. So this topic, modern physics, will be like this, very troublesome. Sometimes we may assume HC has certain values, but sometimes it will not mention. Sometimes he will mention specifically only that has to be taken. And this also you have to be very careful. Okay, solving this, we'll get the expression for saturation current. Saturation current will be variable or constant. Saturation current will be constant. I'll write it. So finally it will be, don't write 0, just 3 ampere is telling. So what is this? This is a photoelectric effect where a chromatic light is incident on a plate. This is the approach. If a chromatic light falls, okay, this is the approach.